Ideally, if you do all the homework and you try all your things, I will not I will not give you a C. Ideally, is I will give you opportunity where you can actually earn a C by your own. But to get a C from a B is kind of hard. From B to an A is very hard. So in each class like this, I will probably have class of 25 students. I probably have 5 A's at the most. So if you want an A, earn legitimate A, it's kind of hard. Now also you can earn at the end of the year, or the following year, I can change your grade if you did well on your AP exam. So there's a multiple path, not just only one path. Um, so let's do that. So we're gonna start with idea of limits. Sorry, calculus. We're gonna give you overall scope. Calculus is um, start with limits. Um, what do you guys know about limits from last year? What do you know about limits? Limit notation. Okay. Okay. Anybody else? Asymptotes. Okay, I can see that. What else? Poles. Interesting. Yes, agree. Anything else? That's it. Okay. So we're gonna tell you that in a second. Using limits, I'm gonna go to derivative. And after derivative, you're gonna learn about antiderivative. Okay, you're gonna go through this process. And it's pretty much like limit is the building block of all the things. So you gotta start understanding about limits. Now, we're gonna say, well, what is limits? Limits, like the way I kind of think about it in term like in the human language instead of just a math language, I think about um, pretend that you can be there, and what happens if you get there, right? Um, and you're approaching from both directions. So that's very vague. So I'm gonna demonstrate to you of what actually happened. So I need a volunteer. Caden? Okay. Caden, all right, sure. Come up to here. Um, yeah. So you're gonna stand on that side, I'm gonna stand on that side, right? Go back up more. There you go. Okay, so the idea is, what if there is a black hole right above, right here, this dot between the tile across each other, right in front of the end, and there's a black hole over there, right? And we says, and me and Kaden says, we want to make sure nobody step on this black hole, but we need to find out the location of this black hole. Okay, how do we do that, right? How do we do that? Now, you cannot take a GPS and just stand on top of a black hole. What will happen? You get stuck and you die, right? If any way I want to die, I will want to be that way. Like that's probably the most beautiful way to die. You get stuck in the black hole, right? You're probably gonna scream for half second, and you're gonna be like, ah, and then like a couple minutes. Okay. I think it's probably faster than that, but I'm not. I know I heard you turn to spaghetti.
Like I think
Spaghetti.
closer and closer. Like I don't know. I might just be.
You're probably right. You're probably right. I think that's looks like acid. But yes, you're probably right. So I don't know, but I heard like I watched a YouTube video like how people says you turn spaghetti or something like that. Spaghettification. basically that's the idea that you want. I think that's beautiful. So if I ever die, I want to die. Okay. So that we want to prevent people step on this location. So we say we gotta find out where the coordinate of this location. So what we're gonna do is we're gonna take it like a GPS and we're gonna track where we at. So let's say Cadence on that side, I'm on that side. I'm gonna slowly approaching this black hole without stepping on the black hole. So I'm gonna take one step. He's gonna take one step. You take 2 steps. Go back up, back up, back up, back up. We're gonna approach one step. You take 2 big. Slow step. Yeah, there we go. So one tile at a time, right? So then we're gonna do it again. Hopefully, like we're not dying yet. Then because the black hole is somewhere in between. So we're gonna take another step. Gonna take another step. So we're gonna take another step. We can go forward, right? So then we're gonna take one more step, right? So don't worry, he's not my type. So we are approaching this slowly, and you did that with your sibling. Anybody have siblings before? Anybody have siblings? Okay. So your sibling probably come up to you. How many times does it happen? So I'm not touching you. I'm not touching you. So Gabby says this. Oh, okay. Is that younger sibling? Or
Yeah.
Younger one to bother you?
Yeah, he's really annoying.
He's really annoying.
Yeah.
How old is he? 14? Still acting like that when he's in this school?
Yes, yeah, he's a sophomore too. I mean, a junior too.
Yeah, I know Will do that to you.
He's 19, he still loves me.
Will just touch you like, oh, they touch everybody. No. No, you know what I'm saying? Baseball players, they're very touchy. They're other boys. I'm not doing it. Okay. The other boys. Okay. But anyway, we try to find a black hole. We try to approach from both ends. The key word is both sides. So we have to approach at both ends. We can reach this specific spot. And we can approach slowly until we get infinitesimally close. And we can judge this coordinate. We can take the coordinate of Cadence coordinate and my coordinate. We can average together. We can figure out, okay, this probably estimated this is a black hole. So the idea, we're going to do that to our functions, right? So you say, okay, well, how is our function going to work? If you really think about it, right? So what kind of function I'm thinking about? I'm just going to think about a function and you guys tell me what they look like. So this first function I want to talk about is f of x equal to x cubed minus 1 over x minus 1. So if you're good at algebra, you probably will figure out what this function look at without using graphing calculator. So let me ask you, how many of you guys know what this function look like? Raise your hand if you think you do. No? You want to try?
Not really.
No? Because you raise your hand, I don't know if you...
Idea, but I don't want to be.
Okay, that I have an issue with. Okay, the problem is I don't want to be wrong. Dude, you're going to be wrong a lot. Get used to it. And you cannot afraid of being wrong. Because if you're afraid of being wrong, you're never going to grow. Very, very key information. Besides the math, I also teach you how to be a life learner. Life learner is you're never afraid of being wrong. You take a wild guess if you have to. But don't be afraid that you're wrong. The problem is, the problem is not being wrong. The problem is if people help you, like give you the right knowledge and you still don't want to change, and that's where it's bad. So it's not a problem being wrong. I always tell students that don't be afraid of being wrong. So what? People gonna laugh at you. Who gives a shit? Don't give a shit about what people think of you. At least you have tried. Other people did not try. They don't have no idea on their own. They are soulless, right? They're afraid, right? Stop being afraid of your ideas to express your ideas. Never, because you miss 100% of shot you don't make. There's a possible you make them, right? But if you don't take that chance, you'll never get girlfriend, boyfriend, or whatever, right? You never have a shot at doing it. It's okay. Ask the girl out. She will reject you. So what? That's just the way it is. You're gonna try. So what's your idea? What do you think the graph look
I
like?
think it's like one of the wings that goes. That's a bad drawing, but it's like
Okay, could be. Yes, Gabby.
I think I'm remembering something else, but like, is it like the multiplicity with like the exponent 3? Does it have to do with whether or not it goes like through the that x?
Okay, you had the same ideas. Eli?
Like, can I try drawing the board?
Sure. Marker. Here's a marker. You can draw on this board. Anybody else?
You're like,
Okay, I think you guys all have some idea. Are you guys all have some teacher? Who's your teacher? Eli.
Mr. Ollie.
Ollie. You have
I had Mr.
Kench. Okay. Anybody else have different ideas? So that's pretty much everybody have some idea because Ollie, Kench, they have some idea. Anybody else? All y'all gonna get a girlfriend or boyfriend. Yes, Kaden. Sure.
Well, it's just it can't be one. Like if there was like one. Oh. And then
Possibly. I don't know. Anybody else? Yes? What does it look like, Kaden?
draw it there.
You can draw up there if you want. Make you feel comfortable. Fine. It's okay to be wrong. Think. Without graphing calculator, can you figure out what a graph look like?
Like that?
Okay, possibly. Anybody else? Shh. I like the discussion. I hear a lot of things. I hear asymptote. I hear what else I hear? Somebody says what? A hole?
Yeah.
Okay, okay. All right, so the discussion is good. The discussion is good. But nobody have really come up the things I'm looking for yet. Nearly, you have something to add? Okay, so that's the same idea as Brendan and somebody else. I forgot. Somebody draw that asymptote there. Liam, right? Okay, then. Okay, Kaden. Okay. But it's not. I don't think it's there yet. Anybody else? Okay, Brendan say something else. What did Brendan say? Say out loud.
Yeah.
It's parabola?
I think it's a parabola with a hole. Yeah.
It starts going.
Oh, there is well.
All right. So we're gonna graph it, see what's right, right?
You have to put it all. All over.
Good job, Brendan.
Wait, that's a good
Okay, so but there's something special about this problem more than any other thing. What else is special about this problem? Yes. Wow, Bennett. On a broad start, you actually pay attention, huh? Okay, so let's check if the thing's right. So I'm gonna go in. Do you see anything different? Yeah, there's a hole. Yes.
I understand how you can tell if there's a hole at one, but how can you tell if it's rough?
That's a good question. Ask Brendan. Well, that's not the reason why, though. That's a very bad reason. But that could be a reason, but it's not.
Oh, so it's like okay.
Armin, what you saying?
I mean, mine isn't like 100% right, but I was like, whenever you plug into the top that's behind the y-axis, right? It's gonna make the top negative, but the bottom will also be negative already. So it's just negative over negative, which is positive. So
That's not exactly a reason, but we'll get to that. It's okay. So we find out that is the thing. So now we're gonna talk about, according to here, there's a hole and there's a graph. So we're gonna look at this particular question. But first thing I want to talk about, how do you look at calculus? How do you look at calculus? Because we always tend to look at calculus using algebra perspective. But that's one of the aspects you should pay attention to. But there are other aspects. So if I really start with the calculus perspective, the first perspective is always numerical approach. Numerically, you look at a number and you plug in and see what it is. That's the first perspective. That's easy. Second, graphic. If you look at graph and you tell me what is it. So in terms of every calculus question, I need you to actually start thinking numerically, graphically. The third is a very popular one. Everybody tend to do this one because everybody feel like most comfortable with. It's algebraically. But without other perspective, you're not gonna go very far. Even though algebra is probably 50% of the time. Graphically, it's probably 30% of the time. Rest of the things is number 4. Really hard to do. And that's what I'm trying to challenge you guys to do, is I'm trying to ask you to think about a graph without graphing calculator. That's called analytical. I don't know how to spell analytical. N is analytical? No. How to spell analytical? How to spell it? A-N?
A-L-Y-T-I-C-A-L.
felt wrong. Hi there. Yeah.
Yeah.
There's one.
I only have one more.
Oh, there is. Oh, no.
Analytic. Okay, I see. Okay. That's why I'm a math teacher. Imagine me teaching English. Okay, so analytical is the hardest thing to approach. So that's why I'm always challenging you. What does the graph look like? I'm going to ask you a few more times, but this is one of the things that people have to understand. You have to look at all this perspective. Yes, Kaden?
The percent of the time that it's normally like shows up analytically.
What? No, what are you saying? Sorry, I cannot hear your question.
You mentioned that 2 and 3 show up a certain percent of time. What's the amount of time that analytically shows up?
Probably 10%, but that's the highest level of the 10%. So let's just say if you want to score a 5 on AP exam, and they can do that. So for example, some people are very bad with algebra, and some people are very good at analytical. One example is Ian. Ian, the chemistry teacher's son. He's a very analytical person. Like if you ask him what a graph look like, he can figure out most of the time. But algebraically, he's bad. He's horrendous. But the thing is about him is I like that he has very analytical thinking skills. Okay. But algebra skill, he just need to improve. Everybody need to improve on something. He just need to improve on that perspective. So those are the 4 perspectives that you're gonna use all the time. Yes, 50% of the time that we're gonna deal with algebraically. And there are probably 20-30% of the time you're gonna deal with graphically. Numerically is probably like 5%, and analytically probably another 10%. But that's all give and take. Don't take my word for it, just roughly that way. Roughly, that's how much time are we doing different things. So now, what do you mean by we're gonna approach numerically first? So what I do that. So I want you to get a decimals. I want you to use with decimals, and I want you to do I want you to graph this function first of all, and I want you to be able to come out a table. So you click on this wheel on the top, this wheel here. So I'm gonna do it again. It's right here, the wheel, and you click the table, and it will come out with a table. And this table is actually pretty important because you can plug in any values. So which value I want to plug in? Well, obviously you see 1 is undefined. So what we're gonna do is we're gonna act like me and Caden. We're gonna check from each side, from both ends of direction, coming from 2 different directions, going to the 1 from 2 different ends. Is that okay? So so we're gonna say 1. What's a value that's a little bit smaller than 1? Or left of 1? 0.9. 0.9. Okay, let's do 0.9. 0.9. If I plug in 0.9, I got 2.71. And I'm going to go to the next one. I'm going to say, hey, I'm going to plug in 0.99. 2.9701. If I plug in 0.999, I get 0.997001. I can plug in 0.999, sorry, 9999, right? 2.9997. So that's my end. Now Caden's gonna come in from the other side. Is 1.0001. 1.001, 1.01, and 1.1. Do you see that value is reaching a specific value? What will be that specific value? 3. So as the limit x approach to 1, it seems like your black hole is going to locate at 1, 3. Does that make sense? And that's how I approach numerically. Now, all the time we have the time to go approach numerically because we don't have calculator most of the time. So we're going to have to do it in outer main. But you can also check a graphing calculator. Anytime you don't know what your limits is equal to, the limit's going to go to 1. It's going to be equal to 3 by looking at the graph, even though it's undefined at that particular point. Yes?
That's us now, right?
Yes.
Does it have like these features? Do you know?
Yes.
Yeah.
Not only that, it has a lot of cool features. Like, for example, you want to find the mean of a number. All you guys do is literally type in mean and parentheses 2, 5, 10. They give you a mean. Okay. So there's a lot more feature we're going to talk about, but that is one of them. There's regression. There's all kind of thing. Yes.
I have a question about like the Wi-Fi. I tried inputting like the parentheses little equation that we had before, but it marks it as like too many variables finding x. We tried to find x.
I have no idea what you're saying. Can you show me? Eli, help you?
making it like the wrong coordinates. Okay.
Okay, so for this perspective that we know, also I want to talk about one more thing that they didn't emphasize enough in pre-calc, including my class as well. Domain. What would be the domain of this function? What would be the domain of this function? I think I tested before too. Yes, Armin. Yep. So the domain of function is set denominator equal to 0. So denominator equal to 0 cannot equal to 0. So if the denominator is like x minus 1 cannot equal to 0, x cannot equal to 1. So those are the things that we did. Right? So we know when limits as x approach to 1 of x cubed minus 1 over x minus 1, numerically, I'm going to get a 3. Numerically. So using decimals. Okay, using decimals. Got it? Am I going too fast? Should not be, right? All right, so let's go to the next one. Okay. We're gonna go to the next one. How about x over root x plus 1 minus 1? And this is f of x. Now I want to say what happened when limit x approach to 0 of x over root x plus 1 minus 1. Okay. Now, first thing first, I want to check if you know what is domain of this function. It's kind of hard. If you don't know what's the domain of this function, I want you to graph it and figure out what the domain of this function. But start by figure out what happened when limit x approaches 0 first. What happened if I plug in 0? I get what? What? 0? Undefined? Why some people still say 0, some people say undefined? Yeah, number over 0. But in this case, it's what? 0 over 0. Thank you. 0 over 0. If I plug in 0, I'm going to get 0 over 0. But I didn't say undefined. So there's a new word for 0 over 0. It's actually one of the special situations. There's 6 situations. The one of the situation is called indeterminate. Indeterminate means you don't know what the value will be. It can be defined by using the numerical approach, but we're not able to determine yet. You have to use other means to find it. Does that make sense? So in this particular case, I want you to use graphing calculator. And I want you to figure out what happened when x approaches 0 using the numerical approach. Now, if you consider yourself a good student, you can do is finding a domain without using calculator. Now, if you are a weaker student, you can find domain with calculator. Okay, so I'll give you an option. You can consider yourself as weak or strong. I'll let you decide. So if you're a strong student, I want you to find domain without calculator. If you're a weaker student, you say, hey, I can find domain still by using graphing calculator, because most SAT questions you're allowed to use a calculator, or decimal calculator. So plug in a decimal, see what happened when the x approaches 0. Approaching for both ends. You cannot approach it one end. One end's not good enough. You need to show me a verification from both ends. Come up with the same number, right? Secondly, you can of course look at a graphing paper. And then third, need you to find a domain of the function. Can you do it without graphing calculator? Can you do it with a graphing calculator? Yeah, how can you find a domain without calculator? And if you cannot find it with a calculator, right? Ethan? Easton.
Range of x values.
Yeah, but what is in this case?
Oh, in this one, it's a -1, 0, union, 0, infinity.
How do you know that?
It's a graphing calculator.
Good. So you find out the second tier. That's fine. At least that's one is done. I like that. How about without graphing calculator, can I find a domain? Yes?
I just thought about it as you can't really square root a negative number and graph it, or else you get I. So the lowest number that you can have without getting a negative for your square root would be -1.
Good. Anything else?
I was just thinking about how to make it
Yes, yes, that's true, both. But I think McKenna says something very, very important. Is if inside the radicand, like x plus 1, so there are two situations. They are, first of all, they are denominator. Okay, it's denominator. So denominator cannot equal to 0. So that means x plus 1 minus 1 cannot equal to 0, because when they equal to 0 is undefined or indeterminate in this case. X plus 1 equal to 1. Square both sides. X plus 1 equal to 1. X equal to 0. So x cannot equal to 0. Right? So that means if you have a number line, at 0, it's going to be undefined. Now, what McKenna says is also true as well, is radicand, which is inside, I don't know how to spell radicand. Radicand. I think it's radicand like this. Is inside the radical is greater or equal to 0. So it'd be x plus 1 is greater or equal to 0. X has to be greater than -1. So it's going to be a solid circle going this way, except doesn't equal to 0. It's pretty much like this. The solution is going to be from -1 to 0, and from parentheses from 0 to infinity. And that's the domain of the function. Now, this kind of question is no longer very popular because a lot of students don't understand domain. But you guys need to start understanding domain because you're in calculus, so you're no longer in algebra 2 or pre-calculus. Yes?
What's the radicand again?
Radicand is inside the radical. So inside the radical, inside the square root sign. So this is a radicand. So x plus 1 is greater than 0. Yes?
Like an indeterminate and then versus just being undefined.
Okay, indeterminate is going to be, you don't know what a value, you can get very close to that value. Undefined is, you don't even have that value to begin with. I hear there is a possible value like a hole, and we can find out the location of that hole. But, so limits, the way I talk about limits, like pretend that you can be there. Pretend that you can x equal to 1. What would happen if x equal to 1? Right? I suppose undefined is like, I can't even do that. Because let's say 1 over x minus 1. If I plug in 1, it's automatically defined, undefined. 1 over 0 is automatically undefined. 0 over 0 still can be using limit approach to find the rough estimate of the value. But if asymptote like 1 over x, there's no way you can find it. If you plug in, it's automatically infinity or negative infinity. It's not reaching to the same value. Okay. So hopefully that answers your question. Now, second thing, once I use the decimals, what do I get? What is using decimals? What happened with limits? Equal to what? What do you guys get? Should I do it? Okay, I'll do it. Seems like you guys don't know. Didn't do it. X over root x plus 1 or minus 1. plus 1, minus 1 here, right? And the graph is like right here, right? But it's reaching what? By graphing perspective, it looks like it's 2. But we can verify by approaching 0. So it'll be negative 0.1, negative 0.01, right? Negative 0.001. It's almost approaching what? 2, right? 0.001. I'm gonna approach the other side, 0.01 and 0.1. So are they reaching which value? 2. And using a numerical approach, I got 2. Yes.
Is there really a point to see where it is from going?
Yeah, so this is a very good question. It's a point to reach from both sides. The both sides is more like verification. Like imagine that if I'm trying to find a black hole without Cadence help, right? And if I'm going this way, going toward a black hole, I can find the edge of black hole, but I cannot find the center of black hole. But if Cadence on the other side, before we get to the edge of black hole, we can average those two values. We can find out where the center of this black hole is. So it's more like a very good confirmation. Very good confirmation. And with the limits, you should always try to approach from both ends. That's a great question. That's a great question. You should try to approach from both ends. Questions? Now I'm gonna go to the next question. Now this another opportunity for you guys to think. Now put away your phone, and I want you to think of this graph. Absolute value x over x without graphing calculator. Can you think what this graph looked like? So instead of just say, and it's okay to be wrong. So what? Mr. Ye is gonna judge me a little bit. I have Alzheimer. I don't remember what happened yesterday. I don't remember what happened last period. Yes, absolute value x over x. What do you think this graph looked like? Okay. Anybody else? Caden?
I'm just thinking it's a normal y equals x line because if you put a negative number in the absolute value, it's going to be positive, but the denominator will still be negative and it will still.
Okay. McKenna?
I think it's gonna be like a straight line at y equals 1 whenever x is positive, and then a straight line at y equals negative 1 whenever it's negative, and then there's a hole at 0. Well, not a hole, an indeterminate. I don't know how that works.
Good, good, good. Okay. Anybody else? Anybody else want to add anything more? Okay, so let's check if McKenna's right. And I think the yes.
With the y equals 1 line, not
Very good. It's okay. I think everybody have. I think start with Baden to start thinking that x over x, but on the left side is actually negative x over x. So it's gonna be a piecewise function look like this. You guys have never seen graph like this, right? But that's good that McKenna has that analytical thinking skill. This is a very, very great skill. It's challenging yourself to think that something you cannot think about. And that's what you guys need to do in order to acquire that skill. It's really like there is no way that you can practice so many times. You can practice like right here when I said, hey, think about what a graph look like. There's no absolute way to do it, right? There's no absolute way. And that's why analytical is different than the other one. The class is almost over. Okay. We'll finish this out. Again, today has no homework. You guys can come help me grade. More likely, I need you guys to help grade few more paper than one. But I need you to write down the right word for them, and I'll give you an empty paper and for you to work at.
Is there any other people that can't come today?
Did you do bad? You probably did good on this test.
I don't think I did good. I know I screwed up a couple of those before. Because I didn't put like the one I only put positive answers, one in a square root, and I didn't think positive negative. Yeah.
So
It was
I think you
simple
made some mistake
mistakes.
last week.
Yeah, it's the same mistakes I made. Is there any way like I could redo a test just for like 2 points?
Probably not, because I want to finish grading this week.
Okay.
But I probably will give you issue a test that you can do at home.
Okay.
And that's actually good.
Okay. Thank you. Any versions of the test? No, like you're talking about earlier.
Yes, I'm gonna send it on the WhatsApp today.
Okay.
It's different number though, because that way you don't know what's
Yeah.
next.
If I sit after school to grade papers, like how long would it be?
Probably 1 hour.
For like extra points?
Huh?
For 10 extra points?
But do you think you need it? You might be doing well on that.
Yeah, I think I didn't do like the
Thank
thing,
you.
you know,
I only
where
did
it's
plus
fine.
two. Okay.
Negative
Restriction. Oh,
Well, I know the
inverse.
restrictions, but then I wouldn't go like if it was like pi over 3, I wouldn't go. If it was like sine negative pi over 3, but I did 5 pi over 3.
Well, it's okay. We were training you to get better, but it's not right away. But it's fun. You know.
There's a lot of tests, so it would
Okay. Yes.
probably.
What happened,
Me?
Jenny? Yes.
Oh, can I get the alternative algebra test?
That one you got 70 on. You're not gonna have any food when you go home to eat. Your wife, your mom's gonna cut you off completely.
No, it's just I can't stay after school today, so I wanna.
No, I will post on the group chat.
Okay, thank you. No, I just want to tell you, I learned how to take a derivative the other day.
What would Well teach you?
No, Izzy and Rhea, they taught me how to do derivatives and integrals because we need it for physics.
Oh, okay. That's good. That's good.
Bye, Tay.
Bye. Have a good day.
Have a nice weekend.
You too.
Yeah. How's the teacher?
What a nerd taking physics.
I'm taking like a hard physics too.
Oh, what a nerd.
Pray for me.
Yeah.
Standing on silence.
She's not.
I got this stuff and then she'd be like, what's your
All right. Giving back the 10 out of 10. And you don't write a code yet. I'll tell you what's the code in a second. So. Just I have one more. One more. Oh, relax. Okay, you got it. Did everybody got a test? Okay, you can start. And right now the code is gonna. I'm gonna explain to you the code. Oh, yeah, get back. It's just the period. This first digit is gonna be period. So period. So in this case, it will be 7. And your last name initial, first initial, and the last 2 digits of student ID. So student ID is gonna be 2 numbers. I don't know the last 2 digits though, not first 2 digits. So ID, student ID. So write it nicely so I can know what are you. Because a lot of time I'm gonna have you guys. Right there. So period is 7. If my last name is start with a Y, just a Y. My first name is start with D, so YD, and last student UID. You guys can start the test. Fairly easy test. Not hard test.